Hello, audience.
Hi, Klaus.
Hi, Robert.
Yeah.
Sorry, we have at the moment a small trouble with our network, with our connection to the network.
Yeah.
And so
GoTo seems to work. So also welcome to episode 38. And today it's about Obtrusive Light again, in a way. We had already in November last year. We have checked it. We also had an episode about Obtrusive Light in general, more on the theoretical side. Today we're going to show you how it looks right now in ReluxDesktop, because we have since a couple of months and the Obtrusive Light options available in ReluxDesktop, and this we're going to show you today. But before we go into it, and we have also still a small technical issue with the infrastructure here, in order to show it to you. But we start with an let's say an review or an recap of what we had in our last Obtrusive episode. So what it's about Obtrusive Light. So in general, it's something for outdoor lighting. So every light which you do not want to have in outdoor lighting. So for example, lights on the sky, for example. So sky pollution, light pollution on skies. This is something which we try to avoid. There are standards, there are ways in order to calculate this, new ways which we will show you today, and also glaring stuff, also lights on locations where you don't want to have light. So windows from strangers, you do not want to put light from your installation into some strangers' windows and so on.
Yeah, sorry. At that positions, we can re-show the presentation we showed the last time with the ReluxDesktop in our first episode. And the major problem we have with Obtrusive Light and regulations, the standards about, is that we have a lot of standards, and they are kind of national stuff.
Mm-hmm.
And we have requirements to the Obtrusive Light as well in some standards, in some typical standard, like here in the 12464, the light working places for the outdoor working places. We have it also similar to close to the same in the sports lighting and in the European sports lighting standard.
Yeah.
And we have in Germany a special which we call LIE, which is a little bit different from the both above. We have a standard in Austria about light emissions, and also in the Netherlands.
Yeah.
And mainly we have also the target to include also calculations related to the CE 115, which is the basis also from all the standards above. But some things are a little bit different. Also, the standard, the CE 150, includes some things like the UFR value, which is not written actually in the standards above, but it is typically somewhere is a big request about this, because everybody is talking about light pollution, and this is the main factor how to check or to qualify the problems with the light pollution is made in this kind of calculation.
The CA 150 is some kind like let's say an universal international point and base point for all the national specific or European specific interpretations of light pollution, of obtrusive light, and these are a fundamental standard, and this is also reflecting into the other standards. But it's to say the values and also details are really specific from nation to nation. This makes it a bit difficult to do this, and you need to stick to your national requirements on this. And this makes light pollution a bit of complicated. But the CAE 150 is something like an universal approach, and also is applied internationally.
Okay. also in just a little bit to remember, we have when we're talking about obtrusive light, there are typically these three main groups of evaluation. We have on first, this is light on properties. This is typically the vertical illuminance on surfaces, on windows, on facades, or on something like this. We have the luminaire intensity, which is more or less similar about glare problems and emission places. And at last, here on the last side, we have the upward light ratio. This is light pollution, a simple way to detect the light pollution. And we have the luminance on facades, and also the luminance of signs in the sense of
commercial glowing commercial stuff. Screens, big screens in public.
Yeah. Here a little bit of overview. So that we have here in this example, it's a road, and we have here on the road and on the border area, this is the useful light. That's what we want. All the other things is light that we don't want, or typically don't want. So we don't want to have a glare of persons who are close to this lighting installation. We don't want to have a light trespass to the windows of buildings and so on. And we don't want to have direct upward light, or as less as possible. And we also typically don't want upward reflected light. And both together, the upward light direct, the direct part, and the indirect part is that what it's a little bit special for this UFR value. Also in the obtrusive light, typically the areas we have lighting environments, which are a little bit different from standard to standard. So some standards have just four environmental zones. The CE has 5, and but in principle all has this separation. Here we will see a picture about this vertical measuring surfaces. About this vertical measuring surfaces.
Mm-hmm.
Okay. This measuring surfaces, and in all round. And here we will see the picture of this typical situation, also from the earlier presentations, about a typical sports situation where we have to analyze or take care about obtrusive light effects. Here we will see the possibility to how to create this vertical measuring surfaces, and which are typically should be evaluated when we make such a study for obtrusive light. Here a little bit you have to think about it when you make this in a project, that we will not calculate here maintenance values. Typically we calculate maintenance values for sports area or on the road or road lighting. We are talking about maintenance values, and here we have initial values. That means in the beginning of the lifetime of a lighting installation. The next point, the upward light ratio. This, I guess, is the most of you know about this thing. This is just the direct part we have seen in the picture before. And the next one is here about this. There's something a little bit of problem with this sheet. You will see here in the background, this is just a copy about of the C150. And we have now made a sphere inside of the calculation program. I hope we will get our colleagues will solve the technical problem we have in a few minutes. So at that point, we will show you this in the live program. And this is now available that you can make this UFR calculation inside of the ReLux program.
Thanks.
So we will stop here at this situation, and
I will tell you a bit about obtrusive light in general. So the challenge is that we have not just one value to calculate, we have a couple of different, a collection of different values which we need to evaluate in this. So first of all is the vertical areas, which facades or which is other stuff. This is quite easy. You can do it right now with the old versions of Relux. You just need to model and facade and a measuring surface which takes the vertical stuff on it. So this is the less interesting part. It comes more interesting to Claire values, to the K values, which is also possible to calculate with a pencil and then in a sheet of paper. But this is annoying because you need to do it for every single lumina. So this makes sense to bring it up to a software in order to get this stuff calculated.
And in the beginning, you have we have here a new functionality which is called Obtrusive Light, and you start Obtrusive Light evaluation. Before you can use this functionality, you have to choose here from the calculation ribbon, activate this or disactivate this. So this is a little bit to handle it a little bit simpler if you don't interested in Obtrusive Light, so that you don't have all the time here this Obtrusive Light ribbon. You have to activate it here. If not, it is not available. After that, it is available, and you have the possibility to use the functionality. And we have here our small standard to say that, let me, this I want to.
Two spots fields beside each other.
This was
one gray facade.
That was two gray facades.
Two gray facades.
It's a little bit easier. You can also make here. It's a small example with a few vertical measuring surfaces representing the windows. And here are the other. Here is the second one. And one of the interesting things, which is a little bit, I guess, no other program at the moment. In the morning, we heard about that one company has started a similar evaluation, but stops this for
provided maybe an old one.
Maybe.
Yeah. So we have heard this morning that there was or is still an old other application who calculates a UFR, and this is quite specific. So it's or unique because it's not really common to have this calculation, but it's forced to be used in CAE 150 and also in other standards as well, step by step.
And you have here the possibility to activate it, but first we have to make a calculation, and you can add this. You can start a calculation with or without a UFR calculation. The UFR calculation needs a little time, so you don't want to have it at each time when you the planning process about the luminaires. So just at the end, you want to activate this button typically, and then we can start a calculation. We have to use here the calculation process, and after we have calculated it, we will have the possibility to take a look. We make a calculation on a sphere over the scene to evaluate these UFR values in the Obtrusive Light. We will also make a special kind of summary where you have all the evaluation values on one page, or it may be more pages. But now the calculation is done, and I want you to show you this UFR value. So we are calculating here on a sphere above the scene the values, and then at least the emitted above the horizontal, the emitted luminous flux. And in the result overview of such an Obtrusive Light calculation, you will, at the moment it's switched off, I will switch it on. You can switch if you don't want to see it, or if you don't need it, you can activate it or deactivate all the possible, all this elements of Obtrusive Light if you like, if you need it or if you not need it. And now we have here the summary of this UFR value. And in the UFR value, it is the ratio. This is a little bit very interesting. It's the ratio between the total luminous flux above the horizon. This is this value here. This is the point what we are evaluating on this sphere above the scene. related to an hypothetical luminous flux reflected by the surface's areas. Hypothetical because it's only taken into account that if we have only the nominal value which is available, which should be available on the surface, on the football field or the tennis field or the road or whatever whatever it is. It is not used the real value. Here in my example, I'm a little bit many above this. Here we have a requirement of about 50 lux and I have 145. It's a little bit high. But for the calculation of this UFR value, it is only this hypothetical flux related to this area and to this nominal flux, and then we will get this UFR value as it is described in the CEA.
Yeah, it's a bit of weird this value, because maybe you have seen for sure the ULR value, the uplight ratio, with this percentage. It's easy to understand because in our case 0.1% goes out in the sky, the rest comes to the button where it should be, and of the UFR it's something like a reflection, so that the indirect part of the sky, and you would also assume something like indirect parts, so in flux or something. And here we have also in addition in relation to the nominal values out of the standard on specific surfaces in relation to the flux to the sky. This is a bit of weird, but I guess you can get used to it a certain of time, and there's also an reference in the standards to these values. So it's just a first impression, but it will get better by time.
And this value, if you are able to illuminate only your sports field exact with the illuminance which is required, then you will have here a factor of 1. This is a theoretical value which is not possible in reality, but theoretically it would be the best value would be here if it 1.0 is. Okay, also in this result overview, you will see all the requirements, the summaries. For example, here this vertical measuring surfaces. These vertical measuring surfaces, in difference to normal measuring surfaces, you have, after you have activated obtrusive light, you have the possibility to mark them as obtrusive light vertical. This is a vertical measuring surface for obtrusive light, and then it will be listed here.
So just the windows on the facade, and not the sports field actors vertical areas, which you have potentially also in your scene.
And also these values are here not the maintenance value, as I told before. These are the initial values without the maintenance factor included it. But on the normal output here, so that we have in one calculation here, we will have maintenance values which are calculated with the maintenance factor as we do it every time. So we have the possibility to have in one calculation, in one situation, the normal calculation, which is typically maintenance, and the obtrusive light, which should be always follow with the initial values without without these values. You have the possibility here in the settings. This is also when you start with the obtrusive light, the first point you will jump into this dialog where you can choose the way with the standard you want to have in your, so we can.
So your nation, if you are in the Netherlands or in Austria, or if you want to,
and then in that case also the output will change. The output for this value will change according to the correct standard or filled with these values you want to have in according to the standard. Now let me show you also something which is very special. I have hidden this in the things. We have also the possibility for calculating this kind of let's switch back to the LIE so that we have these K values inside. Normally we will calculate these K values or these Claire values on observer points. This is not new. We will have it here. For here you will have a list for all observer point. For each luminaire you will have a result. But to have an overview over a complete area, you have the possibility to put in measuring volume. Normally, we have only measuring surfaces, which are two-dimensional, and these measuring values are three-dimensional. There is already one placed here. I have hidden it. Now I have activated it. Now it's uncalculated. I run the calculation again.
You can imagine it's like an false color overview, but in 3D and not in 2D. So we have values, we have grid points, but the grid points not on the area. We have grid points on the volume, and each grid point, volume point reflects an value of this K factor. And we have thresholds. We have 3 thresholds in it at the moment, where you can have specific values to specific cloud colors. So we can see in a cloud color how many glare effects K value you have inside these areas. And you can see here the blue front, for example.
The calculation has finished, and you will now see in a three-dimensional false color that what Robert says, these 3 levels we have actually for this kind of calculation case. So the limit values are typically this 32, 64, and 96. These are the typical values, but you can adjust them. You can adjust the colors, and then you will have here these shapes where you also can see how far it is go out of your calculation area. We have also can show here the grid points. It's a little bit confusing, but you have here in just measuring points in a three-dimensional way, not only in a two-dimensional way, which we have typically in measuring areas.
It is also possible to change the grid size in 3D.
You can also
make it more dense.
You have the similar possibilities to change the sizes of the number of points in this way, as you know it from the two-dimensional. You can do more fine or more rough, but it's a good way to test at which position it would be critical, and where should we take a more detailed observation about if there are problems or not. Okay, and at least we have also made there is something which is
it's not bookmarked.
It's not bookmarked here. Just
it's not.
It's just a moment here. Is that?
Yeah. This is called DarkSky. DarkSky is a company, in a way, a company and consortium and an organization. Organization is a good word. Which
it's a classification also.
You can classify your products,
your installations that it's DarkSky approved.
Yeah. So this is DarkSky logo, and as manufacturer, you can certify your luminaires DarkSky complaint. So it means this product does not make so much light pollution, and it's also possible. This is interesting. You can also certify your spot area, your street, your outdoor area to DarkSky confirm. But this means you need to have to apply to the DarkSky standard, and there's an DarkSky guidance / standard which you need to apply in order to be certificate with your spot fields or with your spot is specific to spot. And we also adapted in the latest ReluxDesktop version. We also adapted this DarkSky requirements. There's a document you can free download it. This is a standard which is for free, so everybody can download it and check this. And here we have some quite specific DarkSky specific stuff, which is not in the CIE 150 or in other national standards. So it's down to this target area here. You need to have a ratio between target area and rest of it. So the light should go mainly into this target area, which is defined here, and not in the rest or in the sky.
Yes, so this is about the rule is about that you're in this target. So the green one is the field of play, that's the sports area, and this additional area around the complete area is the target area, and then at least 85% of the luminous flux of the complete installation should be inside of this target area. Then we have here also around in a range, in a distance from
46 meters.
46 meters around this area, you should check that the luminous intensity should not be above 1000 candela per square meter. And we have added in the program also in our Obtrusive Light a special output to bring all this outputs here inside of the things. We have here implemented here. This is a project where we have this, and we have here also all these observing points for the luminous intensity around the sports area, and here the target area. I guess it is also fine when you use rectangular surfaces. We have here for sample reasons and for demonstration reasons a little bit accurate as it is printed with this nice corners. And then in the result output, you have here in the Obtrusive Light, we have here also the possibility to show it was already on the UFR off, and I just want to see now that the target area, the target sky, and here it is now in this project is close to 95% of the installed luminous flux is on the area, on this target area, which is inside.
And this is good. So it hits the requirements, and so it's confirmed to the DarkSky guidance.
Yeah, and then we have here also the possibility to check the luminous intensities, which is here limited. I have chosen here this from the normal standards here, so that we have here to check against the limit from 1000 candela.
Yeah.
Okay, so we apologize for the trouble a little bit, but that's the point when you're. But this is also a little bit the reason why we make this live.
Yeah.
Do not recording this.
Yeah.
So
there are no second attempts. Everything is live. It means the technical quality is not always the best, but step by step it's getting better. And so we come to your questions. Yeah.
Let's take a look if there are some.
There are some. I can see in red marker. Potentially we get a lot of technical complaints first. Let's see. Okay. I think the screen sharing is not.
Yeah.
Yeah. Okay. Yeah, the screen sharing was not on the right screen. Oh, you have seen the presenter view. It's at least you have seen a tiny area of the presentation.
We should take.
It's exactly the same like in the November last year episode.
It's a little bit a problem that we could not really see these questions in the beginning. So we must open a special.
We could see it, but it's a bit of fuzzy with all the screens and yeah, and also it's we need to concentrate on the questions on the side. Okay, all of your comments related to the screen. Okay, does Relux use the luminous sources method in CAE 150? Or the old formula shown in 12464. We're using the new one. We're using the CAE method for the. Actually, we can have both in a way. So
yes,
both is possible.
But I'm not sure if this is. I'm not really sure what is. On which point this is related, this request, because about the luminous intensity, we have still the luminous intensity in the same way as it is, and we have it for the CEA to check the maximum allowed luminous intensity related to the projected area of the luminaire.
I guess this is the point.
This is the point. When this is the point, then it's.
There was also the old method is also from CA 150. There's an older CA 150, I guess from 2008 or 9 or 7. I'm not sure. There's an older CA 150, and the older one is applied in 12464-2 and also in the current 1293, the sports lighting standard. And it takes years in standardization before they adapt to the new one. And in spotlighting, actually, we have an rework of the 1293, and we're going to also to apply the new CAE 150. And the biggest difference between the older and the new CAE 150 is the projected area in this of the intensities and these factors. And yeah, this is going to be changed in all the standards by time, but it could take a lot of time before you have applying from one standard to another. This is not easy, but you actually you can do both in a way.
Okay, how high is the dome? Is that dome above the model? This dome will automatically calculate it so that it's larger than the complete scene. There is a factor inside how larger it is. We discussed also this in the morning. At the moment, there are no experience about these things, but it's for the result, it should be irrelevant. How large it is, it must be large enough so that it can collect all the light which goes above. But for the result, it is in principle irrelevant. Okay.
It covers the whole scene in short. And of course you can scale it, but it's just about the resolution of the, let's say, of the false colors. It has not a physical impact how much the systems, because the light is going out of the scene and it's reflected on the dome.
Yeah.
Can you give an example of the need of a measuring volume option in a project? Of course.
It is a little bit, if you have a large area and you want to check at which areas or in which ranges we will get in problems with the borders of the Clare rating or something like that, then you can start placing single points. But you can also use this measuring volumes, and then you will see in a kind of overview, where are my critical areas? And then in these critical areas, you can have a more detailed analytic. So there is not a requirement from a standard or something like that, but it's more the tool to help you as a planner, and also to a tool to illustrate your work so that you can see, okay, look with this installation up to a distance from this point, there will not longer be any problem with this Clare values.
It would be possible to have some kind of a map, so some kind of clearing map. You can illustrate. You can have a map on in which area your sports area, your stadium is harming and glaring other houses or other people around you. And with this, and we have now in 3D kind of map. You can see. You can also have seen if you going back in this video, you can see. Okay, this blue area was large, but this is not so just a lower value of this glaring K value, and the higher ones are going more to the center of the stadium. And now you can see on the map which houses has which kind of impact in glaring of your installations. And the smaller this area is, the better, of course, and you can easily show, okay, on the map, because they have certain heights. So this is why it's not so possible to have it on the map. It's also possible to flat this down to just one Z level, but then you have a window in different heights. That's why we have this volume objects, and you can see, okay, the window on the same facades in a higher flow has less effect as in a lower flow by this volumes. And of course, it's a nice way of analyzing your glaring situation of this volume entity. Yeah, but of course, for standardizations, you don't need to have it. You need certain values on certain facade points.
Okay, the next, in what mode is the DarkSky measurement area? This is not a special mode. This is just a measuring area. It's about the evaluation. That what you only find in that what we call DarkSky. You have to place this targeted area is defined in this DarkSky standard. You can read it here. This is also the next question. What is the DarkSky guidance called? You can Google this find this by DarkSky International. If you go there, then you will find the page where
DarkSky.org, I guess.
Yes, DarkSky.
Can you open the PDF files and we can name the standard again? The PDF file.
Moment. This is.
Then we can tell you the name. of this document. It's DarkSky approved outdoor sports lighting program version 1.3. So the outdoor sports lighting program from DarkSky International.
Yeah,
this is a document. You can download it for free. We have done the same, and then you find all the details on, I guess, 10 pages.
Yeah.
10 pages.
Yeah, it's in principle it is the same what we are doing also in this other obtrusive light things, but it's a little bit more detailed for DarkSky, so about the light pollution, less the problems about clearing and so on.
Yeah,
it includes this also, but it's a little bit and then you can download and you can use it. Can we see an example on a facade?
We have seen.
It's a little bit. Sorry, it's a little bit.
You can also. We have just showed you a list. In the results, you have a list of all the facade parts where we have measuring areas. Potentially the windows, which is the most sensitive part on the facade, if it comes to light for non-wished or non-liked lighting. And of course, it's possible in Relux that you go down to each single window or to each single facade area and have a fault color or a table of values. So this is typical for Relux. You have a lot of output options, but in the summary of the Obtrusive Light, you have just one line representing one facade element with their values.
No, so you can also, you will find a tutorial on our homepage there. You will see all the points, what is necessary. We have also this, I haven't shown this, but we have a special tool also implemented so that it's much easier to place these vertical measuring surfaces in front of facades. It's a kind of, we call it object snap. You can also use this for other measuring areas. It is not only for obtrusive light. It is for example, if you want to make vertical measuring surfaces in front of an
object
model,
shelf,
in front of a shelf or something like that. An interior whiteboard, interior scene or something like that. So this is very helpful.
Snaps. So vertical areas which snaps to it. Also, a nice feature is in the properties of the result output, you can also select how many of this stuff you want to see. If you want to limit it down to just the worst ones.
Yeah. So that the print outputs, for example, in this DarkSky, we have a few hundred of these observing points, and it doesn't make sense to print them all. So you have just to print the worst ones.
The worst five.
The worst five should be enough. What are the costs of this module?
You have to check our shop site, how much it is.
At the moment, there is a free self-study course.
Yeah,
when you buy
a license, there's a free self-study course, but till end of October, if I remember correctly. And check our shop for your donation. There's also a free test of you can have a free trial. So you have with your normal ReluxDesktop installation. If you click on Obtrusive Light, you will get a pop-up which brings you to the shop. But there's also, you can also activate a free trial of 7 days, and then you can give it a try. And later on, is it the price for all the regions? What's just okay? The price is $899 for one license. As a network license, or just single? This is for single license. There's also network licenses for another price. Check our shop, but before you buy, check the trial, give it a try, play around with it. Send us your comments, and since there's also a free self-study, you can check all the functionalities, because it could be quite complicated. It's not just one value, there are a couple of values which you need to have in line with a lot of different standards down to the national level. This could be complicated.
Okay, is it possible to calculate obtrusive light for street lighting? Yes and no. Yes, in the street lighting we have a simplified calculation model. So some issues are not so simply transferable, but we have also in the street lighting, I haven't showed it, you have now the options to add facades on the left and the right side. So you have a simplified obtrusive light calculation for the facade lighting, also in the street project. And then you have the possibility to convert your street scene into an exterior scene, and then you can calculate the UFR and so on.
And facades.
And on all you can set this glare points for K calculation or luminous intensity calculation. But we should think about it if we make this also directly available in a road scene. Do you know if C150 will be integrated into new 12464 Part 2? Yeah, there is a discussion, I know.
No, it's the question what you mean with the new one, because there's one out in this month, and this one has the old. This one, the current one, the actually one has the old CA150. There was a couple of reasons in working group 2 of CC 169, and they decided to go to the old and not to the new, which is, in my mind, a pity. One of the reasons were that there was not calculation options to do this, which obviously was the case, that we could calculate it. And I assume the next renewal, which could take 2 to 4 years, depending. So a couple of years, but I guess the next one will have the new standard. As I said, we're going to renew the sports lighting standard, the European one, and this will be, we are on the beginning of this, but a couple of experts want to go to the new 150, including me, and we will see how the end will be. But it also takes by minimum 1 year before we have the new sport lighting standard. Yeah, step by step. As I said, it takes years in standardization. Is it possible to show by your new tool bug ratios for lead certifications for individual lighting? No, we have not the bug ratios in our tool. It's on our wish list, I have to say, but you have not so many clients in the States or manufacturers which going to calculate bug, and it's also something which is more related to the lumina and less to the installation. So maybe on the data sheet or something, or in Relux Analyze or some other tools, then it's it's easy to calculate. It's just a question where to apply this ratio. Can you make the export of your results easier? Depending, but yes, we should. We use the output in different reports, such as would in InDesign. Oh, okay, in InDesign, exporting results from Relux is painful. Yeah, it depends. We have the PDF output, and you cannot easily pick the text. This is we are aware of it. Of course, there are fancy tools like OCR to getting out. Maybe you try not to stick to the PDF output. Maybe you give it a try to export DWG, or taking something like the Enscape real-time rendering out of it, or even screenshots of different sections, depending what you compose. But if you're using InDesign for your reports, then you should not just stick to the PDF outputs, and you should getting directly to the application. Even if you a bit of techie, you can also export a lot in XML or in Excel tables out of Relux, and try to use this pure result values to express yourself in other layout applications. We need to go in detail. So if you have specific requirements to our output, then please send it to support@relux.com, and then we can check it and put it to our wish list and understand what you need in detail on the printouts. And then, of course, it's possible.
And here, many thanks for naming the DarkSky guidance. You're welcome. Croatia has legal limit values on lux values on resistance windows. it would be useful to include these measurements in the program when calculating street lighting.
Need to convert to an external.
Yes, I guess this is here. It's one more national standard. So if you can please send us this standard, maybe it would be helpful. It would be helpful if it is in English also. Then we can take a look if we can add it also to the
list, to our Obtrusive Light standards. Yeah,
to the standards.
We should come to the end. Last
yeah,
question.
This is the next one. Is there a way to nicely type some text on Relux front page without lines being stuffed left or right from different lines? Okay, we know that this, and at that point we have a little bit the possibilities to optimize our things.
Yeah, it's a question what you want to do with the front page printout text. It's just intended to have some description and text on it, but of course it could be a set of more options, text options. Good. Okay.
Okay. The last one in DVK export here, we have to make some. There are some points actually missing. We are working on this. Okay.
The dome is not in DWG exportable at the moment. Okay.
Okay.
Then thanks much. Sorry for the technical trouble in the beginning. And we will see us again, hopefully, on our next episode. This will happen on the 17th of October. Also Thursday, same time, same weekday, and so on. And the topic will be IFC. Since a couple of weeks, months, we have IFC and IFC import in ReluxDesktop as a beta state right now. And we will show you in the next episode, what is about this IFC import, what you can see, what you can expect, and with a couple of samples, what is the look and feel, and what are limitations and what are options with this import for indoor, outdoor visualization, calculation, and so on. So this will be IFC with Relux by the next episode. So yeah, see you and stay tuned.
Okay, thank you. Bye.